In our lesson today, we are going to go over the inverse of log and exponential functions.
One of the most popular choices by parents in the Bay Area is Tutoringisus. We offer college advising, tutoring services, SAT and ACT test prep all under one roof. Where hard work achieves dreams, Tutoringisus is here to help.
So the first thing we need to learn is using the inverse properties. By definition, if we have a function that is g of x is equal to log base b of x, then the function f of x equal to b to dx is its inverse. If we have log base b of x and we need to undo the log, then we raise this to the same base. So now b raised to the log of b of x, these two will undo each other, and this will equal to x. On the other hand, if we have an exponential function, b to the x, if we need to undo the base, then what we do is just take the log to the same base, and that will equal to x. Let's work on some examples. Problem 35, it says that 7 raised to the log of the same base of x. These are inverses, they cancel each other, so this is equal to x. Problem 36, same thing, we have 3 raised to the log of the same base, which is 3 of 5x. This will also equal to 5x. Number 37, we have a natural log. That is a log to base e. So it is raised to the same base. So e, natural log of 4. The e and the natural log, they cancel each other, and that would be a 4. Number 38, we have a common log. It's raised to the same base, which is 10 for the common log, log of 15. This is going to equal to 15. Number 39, log base 3 to 2x. This cancel each other, and this is going to equal to x. And number 40, the natural log e to the x plus 1. These are inverses, cancel each other, and we end up with x plus 1. Here's the steps that we need to follow to find an inverse of a log or an exponential function. The first step is to switch the x and the y. Next, we need to apply the inverse properties to isolate y. And lastly, we just solve for y. Let's do some practice problems. Problem asks us to find the inverse of the function. Problem number 43, we have y equal to 0.3 to the x. That's an exponential function. We need to find its inverse. First thing, we need to switch to the x and the y. So we'll have x equal to 0.3 to the y. Now we need to apply the inverse. Since we have an exponential function, we need to apply the log to the same base. So what do? We take the log to the same base. And now these cancels each other, and we end up with log base 3 of x equals to y. Problem number 44, y equal to 11x. Switch the x and the y, x equals to 11 to the y. Take the log to the same base, log to the same base. This cancels each other, and we have y equals to log base 11 of x. That's the inverse. Problem number 45, y equal to log base 2 of x. Switch the x and the y, x equals to 11 to the y. Take the log to the same base, log to the same base. This cancels each other, and we have y equals to log base 11 of x. That's the inverse. Problem number 45. Y equal to log base 2 of x. Switch the x and the y. We have a log. We're going to raise it to the same power. Now we have 2 to the x equals to y, as these cancel each other. Problem number 46. Y equal to log base 1/5 x. We'll raise this to the same base. And now I have 1/5 to the y. This cancel each other, equal to x. Problem number 47. Y equal to the natural log of x minus 1. Switch the x and the y. X equal to the natural log of y minus 1. The anti-natural log is e, and I raise this to the e. Now I have e to the x equals to, this cancels each other, y minus 1. I move the 1 to the other side, and now I have y, this cancels, equal to e to the x plus 1. Problem number 48. I have y equals to the natural log of 2x. X equals to the natural log of 2y. I raise this to the e, and I raise this to the e, and now I have e to the x equals to 2y. I divide both sides by 2, and I end up with y equal to e to the x over 2. Problem number 49. Y equal to e to the 3x. Switch the x and the y. Take the natural log this side. Take the natural log here. This cancels each other. Now I have natural log of x equals to 3y. I divide both sides by 3, and I end up with y equal to the natural log of x over 3. Problem number 50. Y equal to e to the x minus 4. Switch the x and the y. Take the natural log. This cancels. Now I have the natural log of x equals to y minus 4 plus 4 plus 4. This cancels out, and I have y equal to the natural log of x plus 4. Problem number 51. I have y equals to 5 to the x minus 9. I switch the x and the y. X equal to 5 to the y minus 9. Since I need to isolate the y, I have to move this to the other side first, plus 9. So now I have x plus 9 equals to 5 to the y. I'll take the log to the same base of this side, base 5, and I do the same thing to this side. So this cancels each other, and I have y from this side, and it's going to equal to log base 5 of x plus 9. Problem number 52. I have y equals to 13 plus log x. This is a common log, so the base is 10. And whenever I have a log or an exponent and I have a number next to it, I need to isolate it so I can take the inverse. So the first thing I need to do is to switch the x and the y. So now I have x equals to 13 plus log base y. I need to free up the y. So first thing I need to do is move that 13 in the other side. X minus 13 is going to equal to log base y. This is a common log, so I raise this to the 10, and that will cancel each other. And I have to raise this to the 10 as well. And now I have y equals to 10 x minus 13.